next challenge is entitled Longest Common Ending. Write a function that returns the longest common ending between two strings. The notes say return an empty string if there exists no common ending, and we can check the examples. Consider the words multiplication and ration. We can see that they both end in A-T-I-O-N, right? They would differ if we grabbed one more letter. The C would be different than the R. So this is the common part, and that's precisely what's returned. With potent and tent, you see tent is output. I think that one's pretty clear. And then skyscraper and carnivore get nothing because the last letters are R and E, so there's no match at all. I think we're good there. We'll go over to code, and please pause the video and implement this yourself. Come on back when you're ready. So I don't want to, you could reverse the strings, to sort of count from the front equally. That sounded like extra work to me as far as for the computer. So I didn't want to do that. I'm going to just maintain separate indices and read from the back of each string because they could be differing lengths. And another thing to note is, if you remember the case with potent and tent, once you've read the length of the shorter of the two strings, you can stop processing, right? There are no extra letters in the shorter word that could possibly match with the longer word, so you're done at that point. Okay, so we'll get into it. Basically then, I'm going to make a helper method. And I'm going to offload a lot of the work here. Let's call it get last common index from rear. And that should take a string, two strings, string 2. Okay, so this will go through, compare the two strings, match letters from the end, and then tell us the index where they differ. So if we have that, we can say something like get index, get last common index from here, string 1, string 2, right? And if we know that, then we can simply, once we have that job magically done for us, we can simply return string 1 or string 2, shouldn't matter. You recall the substring method, right? Where we can pass an index value, and we'll use the single parameter version. If you use the double parameter version, you can also specify how many characters to read, but we just want to take everything all the way to the end, so we're only going to provide one parameter. And that will be whichever string we chose that we called this on. We'll take its length, and we'll subtract that index, right? Read back that many characters, and then take the rest, read all the letters to the end. So it becomes pretty easy once we get this guy figured out, right? And then it might be helpful to show you can see where they end. And this could help us if we're running and something goes wrong. So then, the heavy lifting comes down to here. Now, for getting this, I mentioned we're going to maintain two indices, one for each string, since they may be differing lengths. So let's do that. Let's call them index 1 for string 1. It'll be string 1 length minus 1, right? We're going to start reading, to do length minus 1 so we don't read outside the bounds of the string. Similarly, index 2 will be string 2.length minus 1, and that'll start us in that end position. We're going to be reading from the back, right? Then we'll have a variable that will increment as we match characters. We'll call it common index from rear. I'm going to initialize this at 0 to start, and then basically each time we have a match between string 1 and string 2, we'll just bump this value up. And will eventually be what we return. So we can add that in, return common index from rear. And then we have the work of iterating over the collection now, right? And so I had mentioned that basically we only have to process the length of the shorter string. Once that's exhausted, it's not possible for any more characters to match than that. So I'm going to make something simple that will give me the length of the shorter of two strings. And let's call it get shorter string length string. This may seem like overkill putting this into another method, but I really encourage you to break all of your logic out into really small focused methods if you can. So this, you could use a ternary operator here, or you could say if string 1.length is less than string 2.length. I'll just use an if statement here. Return string 1, else return string 2. And I don't need the else because we would have just left the function if this condition were true. So, yeah, you could have put this logic in the other method, but again, you keep doing that with every little thing and you'll find your methods bloat pretty quickly. So now that I have that, I can say, let's call it shorter length equals get shorter from rear string. Oops. It's annoying how this jumps around. String 1, string 2. Now I know I can use this in my loop, right, to determine the length. And we're going to read in reverse order, right? So we're going to use that sort of inverted for loop logic. We could say shorter length minus 1 to start at the end, while I is less than or equal to 0, and then minus minus I. This is reading from the back going toward the front for the length of the shorter word, which is all we need to consider. Then we're going to check if string 1, index 1, is not equal to string 2, index 2, its index, which both started at the end to start. And we'll simply say break, right? We're done at this point. We're going to feed it the initialized value here if they don't match from the start, and that's what we're going to return from our function. But provided you get some matches, we've got to handle that case. We said we're going to bump this common index from rear. Common index from rear. So that's going to say, the first character's match, it's going to bump it up to 1, saying you had 1. If another pair of characters match, it'll go up to 2, etc. And then we have to be sure that we're updating these indexes each time, right? And they're starting at the end, so we actually want to decrement them so they proceed toward the front of their words too. Minus index 1, minus index 2. And then yeah, after you've processed the whole length of the shorter of the two words, this would have been incremented as matches are found, and then you can return whatever value that got set to. And that should do the last common index from the rear. That should satisfy this function, and it makes our job really easy here. Again, you could have put all of the logic I wrote into this one method, but then it gets long and ugly in my opinion. So I would say not to do it like that. I think we've got everything here. I don't think we need to bring in any libraries. Let's try running this and see what we get. Okay, we got a warning. Oh, sure. For the print statement, yeah. You definitely need to use the system namespace for that. Okay, my bad. Is there something else I should be worried about? The name string does not exist in the current context on line 12. Ooh, yeah. See, I had ST2. It should be STR2 from what I was typing down here. Let's try that, see if anything else is lurking. The name string str on line 14. What do we do? Yep, sure enough. Didn't put string 1. Okay. Let's try this. That makes sense. Line 34 cannot implicitly convert type string to int. What do I do on line 34? String to, oh sure. Yeah, I was returning the strings, but I actually want the length, not the string. Okay. See, the compiler can often be your friend. All right, what do we got here? Index 0. Expected string length 5, but with 0 strings differ at index 0. Beautiful. We can see our first test is pitiful and beautiful. We should definitely have that TIFUL. Okay, so why didn't we get that? Let's take a look. String. If string 1 index 1 is not equal to string 2 index 2, minus, that seems okay. String length. String 1 length minus 1. String 2 length minus 2. Get shorter string length. Oh, I see what I did. Oh man, if you want to pause this one and find it, it's visible in where I have the screen right now. So I was in the, that muscle memory where you always do the for loops the same way, ascending. I put less than or equal to 0. We want while I is greater than. Remember, we're starting with a value greater than 0 and we're decrementing it down. So our condition is that I is greater than 0. Basically, we're skipping this loop right away and just returning 0 every time for the last common index from the rear. So yeah, that can be obnoxious. You get these little bugs like that. And okay, let's see if I got this right finally. Hey, that looks better. That's the sound we like. And you can see the index is printed out here. We certainly don't need that in the result. It was just to help us if we were having trouble. And you can see it was helpful, right? We could see it was always index 0 when I had that bug in there. And that's a nice clue too, that, hey, why is it always 0? It's like you get the feeling like the loop isn't even being processed, right? And then you start thinking of how that could happen. And hopefully it leads you to finding something like that. But yeah, that's the way I chose to approach this problem. You could have done it many other ways. You could have reversed the strings and just used one index value to compare both of them. I avoided that in terms of efficiency. I thought reversing the strings wasn't necessary when I could just read them from the back and maintain a separate index value. But your mileage may vary. However you did it, I'd be happy to see your results. Otherwise, hit me up with those questions or let's move on to the next challenge. We'll see you then. Thanks.